Hello friends, in the previous session we have discussed black box testing, which is concerned with the function that the tested program is supposed to perform and does not deal with the internal structure of the program. Thus, black box testing is concerned with functionality rather than implementation of the program. Today we are going to discuss another type of a testing, that is a white box testing. White box testing is concerned with the testing, the implementation of the program. The intent of this testing is not to exercise all the different inputs or output condition, but to exercise the different programming structures and the data structures used in the program. White box testing is also called structural testing, and we will use the two terms interchangeably. To test the structure of the program, structure testing aims to achieve the test cases that will force the desired coverage of a different structures. Various criteria have been proposed for this. Unlike the criteria for a functional testing, which are frequently imprecise, the criteria for structural or white box testing are generally quite precise as they are based on the program structure. Here we will discuss one of the approach for structural testing, or we can say as a white box testing, that is a control flow based testing, which is most commonly used in a practice. Most common structured based criteria are based on the control flow of the program. In this criteria, the control flow graph of a program is considered and coverage of a various aspect of the graph are specified as a criteria. As you can see this in the screen, we have a example in a previous video for a age, and here we have drawn the graph for the same criteria. Perhaps the simplest coverage criteria is a statement coverage, which requires that each statement of the program be executed at least once during a testing. In other words, it requires that the paths executed during testing includes all the nodes in the graph. This is also called all nodes criterion. A more general coverage criterion is branch coverage, which requires that each edge in the control flow graph be traversed at least once during a testing. In other words, branch coverage requires that each decision in the program be evaluated to true and false values at least. Testing based on a branch coverage is often called branch testing. The 100% branch coverage criterion is also called the all edge criterion. Studies have indicated that there are many errors whose presence is not detected by branch testing. Because some errors are related to some combinations of a branches and their presence is revealed by an execution that follows the path that include those branches. Hence, a more general coverage criterion is one that requires all possible paths in the control flow graph be executed during a testing. This is called the path coverage criterion or the all paths criterion, and the testing based on this criterion is often called path testing. The basic aim of these approaches is to select a set of paths that ensure branch coverage criterion and try some other paths that may help reveal errors. One method to limit the number of paths is to consider two paths the same if they are differ only in their subpaths that are caused due to the loops. Even with this restriction, the number of paths can be extremely large. It should be pointed out that none of these criteria is sufficient to detect all kind of errors in the program. For example, if a program is missing some control flow paths that are needed to check for a special value, then even executing all the paths will not necessarily detect the error. Similarly, if the set of paths is such that they satisfy all the path criterion but exercise only one part of the compound condition, then the set will not reveal any error in the part of the condition. The basic aim of these approaches is to select the set of paths that ensures branch coverage criterion and try some other parts that may help reveal the errors. So, in above example, here we are taking the age parameter which will accept the value 18. If the age is greater than 18, the person is eligible. If it is less than 18, the person will not be eligible and the program will start. Control flow based criteria basically requires path testing as well as branch testing. One of the criteria or one of the testing is not actually solely sufficient for the testing purpose. So we have to include both path, branch testing and other criteria as well. Now let's see test case generation and tool support. Once a coverage criterion is decided, two problems have to be solved to use the chosen criteria for testing. The first is to decide if a set of test cases satisfy the criterion, and the second is to generate a set of test cases for a given criterion. Deciding whether a set of test cases satisfy a criterion without the aid of any tool is a difficult task, though it is a theoretically possible to do manually. For almost all the structural testing techniques, tools are used to determine whether the criterion has been satisfied. Generally, these tools will provide a feedback regarding what needs to be tested to fully satisfy the criterion. To generate the test cases, tools are not that easily available, and due to the nature of the problem, a fully automated tool for selecting a test case to satisfy a criterion is generally not possible. Hence, tools can at best add the tester. One method for generating a test cases is to randomly select the test data until the desired criterion is satisfied. This can result in a lot of random test cases, as many test cases will exercise the same path. As test case generation cannot be fully automated, frequently the test case selection is done manually by the tester by performing structural testing in an iterative manner. Starting with the initial test case, Starting with an initial test case set and selecting more test cases based on the feedback provided by the tool for the test case evaluation. The test case evaluation tool can tell which path need to be executed or which mutants need to be killed. This information can be used for further to select the test. Even with the help of a tools, selecting a test case is not a simple process. Selecting a test case to execute some parts of as yet unexecuted code is often very difficult. Because of this, and for other reasons, the criteria are often weakened. For example, instead of requiring 100% coverage of a statements and branches, the goal might be to achieve some acceptably high percentage. There are many tools available for statement and branch coverage. The criteria that are used most often is this. Both commercial and freeware tools are available for different source languages. These tools often also give higher level coverage data like function coverage, method coverage, and class coverage. To get the coverage data, the execution of the program during a testing has to be closely monitored. This requires that the program to be instrumented so that required data can be collected. A common method of instrumenting is to insert some statement called probes in the program. The sole purpose of the probes is to generate the data about a program execution during testing that can be used to compute the coverage. With this, we can identify three phases in generating the coverage data. First one, instrument the program with probes. Second one, execute the program with test cases. Third, analyze the results of the probe data. Probe insertion can be done automatically by the preprocessor. The execution of a program is done by the tester. After testing, the coverage data is displayed by the tool. Sometimes a graphical representation are also shown. So this is all about test case generation and tool support. If you are having any queries, feel free to drop your queries under discussion forum created on your Moodle. Thank you for listening.